Before moving on to the inclined plane problem that I actually want to solve, I want to do a related problem that we're going to be comparing our inclined plane problem to in a second. So I have two masses, M1 and M2, and I want to know the tension of the rope and the acceleration of the blocks as M1, M2 falls. And so I want to draw a free body diagram. So I have the normal on 1, I have the weight of 1, I have the tension, I have the normal on 2, I have the weight. There is no normal on 2. Oh, gotta redraw this. Okay, normal on 1, weight on 1, tension. And then on mass 2, I've got the tension and I have the weight of mass 2. Now, let's actually be careful. So all my known variables, my G, my M, and my G, M1, and M2, I'm going to write those actually as I can't see what I'm doing. There we go. I'm going to write them in purple letters. Well, technically plum, according to my, see, plum. Okay. Now, we're going to go ahead and actually set up our equations using these free body diagrams. But to do this, we need to define what I call a sign convention. So the system clearly moves in the direction of this arrow, and let's be clear what that means. For M1, any force that makes this motion happen is a positive force. Any force that fights that is a negative force. For M2, again, continuing with the sign convention, anything that makes us fall is going to be considered a positive force. Anything that opposes that and points upward is going to be a negative force. So if we actually label our forces on our free body diagram, what we'll see is that here, this part on mass 1, the tension has a positive influence. And for M2, the weight has a positive influence. And the tension here, think of these as two separate forces. Do not make them the same force in your mind. They have the same value, but they're affecting different parts of the system. This tension here, the positive one, affects M1. The negative tension here pulls up on M2. Yes, they have the same value. Yes, they're the same rope, but they're two different forces. Now let's go ahead and set up our equations. So for M1, in the y direction, we're going to actually have our unknown N1. And it has a tug of war with the weight, which we can actually write as mg, m1 times g. And the effect is that those forces cancel. So we get one true but not necessarily useful formula, which is that the normal force happens to balance the weight in this problem. Now, in the horizontal direction, we're actually going to have a little bit of a different formula. We're going to have the tension on block 1 actually makes it accelerate. So the tension pulls on block 1 with the effect of making it speed up. There we go. Now for M2, we're going to actually set up the equation following the sign convention. So we're going to have the weight acting on mass 2 has a tug of war with the tension, and the effect is that our second mass falls, gaining speed. Now let's plug in what we know. We're going to end up getting that m2g minus the tension equals m2 times our acceleration. So there we've set up the equations, and now what I'm going to do in the next video is go ahead and actually solve out for both the tension and the acceleration.